Good afternoon, everybody. Can you hear me okay? It's my great pleasure to be here today. My first time in Finland. I grew up in Germany. And when I was 27, I moved from Germany to the United States, spent 5 years there in Texas, did my PhD there, and then I moved to California, to the University of California in Davis, where I've been ever since. So 20 years in California. And I can tell you, when you think of California, you might think of Hollywood or maybe Silicon Valley. But California is really an agricultural state, a very strong agricultural state, the strongest agricultural state in the United States, twice as strong as Iowa, which is the number 2. So agriculture is very important in the state of California. We have a lot of dairy cows, the most in the United States. We produce 20% of all milk in the country. And have you ever wondered why we have so many dairy cows there? We have such good soils. Why do we have that many dairy cows? We have this many dairy cows because we have 400 specialty crops that produce a lot of co-products, byproducts. And most of them end up in dairy nutrition, in our rations. So we do have a sizable agricultural production, but we also have many people. About 10% of all Americans live in California. They all think they are food experts. They all think they are food experts and know everything there is to know about food and nutrition, how to grow food and so on. But in reality, very few of them really are experts. But they have opinions. And these opinions lead to public policies. Oftentimes it is California that is the first state in the United States to make new rules and regulations and so on, particularly on the environmental side. Now, I am an animal scientist, but I'm also an environmental specialist. I'm an air quality specialist. And this combination is very rare. But it is one that has proven to be very important because the topic of air quality and climate is such a big topic now in animal agriculture. In fact, I would say that the impact livestock has on climate has become one of the hottest topics in and around animal source foods in the United States. Impact livestock has on climate. And here there is one gas in particular that is the Achilles heel of animal agriculture. And that's methane. And so today I will talk to you about that. It sounds very dry, but I tried to make it not dry. I tried to make it as interesting as I can. So in addition to being a professor who teaches undergraduate students and graduate students, and in addition to being a scientist who does research, I'm also an extension specialist. That means that I provide information outside the university to farmers, to the public at large, to policymakers, and so on. I'm also the director of the so-called CLEAR Center, which is a new center that I established 3 years ago. It has 2 main responsibilities. One is research, and the other one is science communications. I am probably the only professor in the United States who has a communication core in his lab. So I have trained journalists, social media experts, videographers working with me, because I think that if there's one thing we are really bad at in agriculture, it is communication. We know how to produce food. We know how to produce food well. But we are not good at talking to the people who want to eat it. We're not good at talking to people making policies and so on. So the CLEAR Center does that. We do a lot of communication and of course research. So we do research, of course. Research projects involve anaerobic digesters, feed additives that you can apply to livestock. We quantify greenhouse gases and air pollutants of all kinds. In short, we quantify the impact animal agriculture has on the environment and particularly also on climate, and find ways to minimize these impacts. Find ways to minimize these impacts. And that's what I will talk to you about today. So on the communication side, we do things such as explainers, explaining things such as what is carbon sequestration, or how do cows affect the climate, or many different topics. And when you Google them, you will find the Clear Center giving you the first answers. Explainers, half-pagers, explaining things in simple terms people can understand. We write blogs, these are longer pieces, and news stories that inform, let's say, journalists who are interested in writing a story about how to write the story right. Because many of them write stories, and these people might be well-intended, but oftentimes they're ill-informed. And you all know what I'm talking about, because we hear this all the time. How many of you have heard or read a positive story about animal agriculture in the last 5 years? Nobody? One, two. Two positive stories here. That's way more than I have seen in 20 years. How come? The story's all negative, right? Is it really true that we are doing such a poor job in agriculture? Is that true that we are doing a poor job? That we are mistreating our animals, we are mistreating the environment, we are producing unsafe food to eat? Is that true? Do our consumers not like what we produce? Is that true? In the United States, 97% of all refrigerators today have animal source foods in them. 97%. People overwhelmingly enjoy to consume animal source foods. Yet all the reporting I read is negative. And I know that's not just in the United States. I know it's happening in Germany. I know it's happening here. It's happening everywhere. And I'm actually getting quite tired of this. And I know that you must be getting tired of this as well. So the stories that we hear and read are these. This is not new to you. I know that you see these kind of headlines yourself. Oftentimes, my center takes on articles like that and we put them into a different context. We explain to people the reality, the facts behind what they write. And sometimes we make ourselves quite unpopular with that, with parts of the media. And when I say unpopular, why unpopular? Because they feel that if you tell the story of agriculture, then you are somewhat biased. Sometimes it does happen that people accuse me of being too close to agriculture. Well, I have news for them. My job is, as an agricultural scientist, to work with agriculture to reduce emissions. Guess what? That means I have to work with agriculture. And I love to work with agriculture. I love to work with our farmers in California. I love to work with them in Germany. Next week, I'll be in Ireland, I'll be in Scotland. And I think it is a noble thing to do, because what our farmers do is feed all the people. Now that sounds very trivial, but you know what? It's not trivial. What are the two most important sectors of society? To me, it is the sector providing health, and it is the sector providing food. And while doctors and nurses are highly regarded, the people producing food are not. Why not? Why not? Maybe we are not doing a good enough job communicating what we do and how we do it. And maybe we need to change. Maybe we need to start working on telling our story better. And I'm not talking about greenwashing. I'm not talking about creative accounting. I'm talking about fact-based information that's communicated in ways people understand. I told you I'm a professor, and many of my colleagues throughout the world are very good at explaining things in technical terms. But when they stand on a podium like this, then most often the audiences will not understand them. Is that true? I think you would agree, right? That's a problem. They need to do good work on the research side, and they need to learn how to talk about it, because the taxpayers are paying them. And the taxpayers have a right to understand what all this research is about. I'm taking pride in teaching my graduate students to communicate science. And when they graduate, they are very good communicators, and we need more of those. So I think that the whole topic of livestock and climate currently has a narrative that is very negative. When you hear the word methane, do you think it's something good or do you think it's something bad? I know everybody in the room thinks it's something bad, right? It's a problem, correct? Well, let's see if that's true. It can be a problem. It can be a problem, but it can also be the opposite.
Hyvin lyhyesti sitten tuossa Frankin alkuosaan kertaus, eli hän on Saksasta kotoisin ja muuttanut 25 vuotta oli Kalifornian ja USA:han ja opiskellut siellä ja työskentelee tällä hetkellä tuolla Clear Centerissä Kalifornian yliopistossa tämmöisessä ilmasto-maatalouskeskuksessa ja he ovat nimenomaan panostaneet kahteen asiaan tutkimukseen ja sitten maatalouden, karjatalouden ilmastovaikutuksesta kansantajuisesti kertomiseen, eli tiedottamiseen. Ja nyt hän tulee tässä sitten kertomaan metaanista, mitä he tekevät metaanin osalta Kaliforniassa ja kuinka paljon minkälainen vaikutus sillä on ilmastoon. Tämä tulee olemaan todella mielenkiintoista.
So everybody has heard that there are greenhouse gases, and greenhouse gases are linked to climate change. But it's not clear to everybody how that works. So let me talk about this for a second. Okay, this slide here shows the sun radiating solar light down to the surface of the earth. And with it, solar heat. Normally, that solar radiation would be reflected back into space if there weren't these so-called greenhouse gases, gases such as carbon dioxide, methane, nitrous oxide. These gases form a blanket over the Earth's atmosphere. And just like when you put a blanket over your body, you keep your body heat close to you, and that keeps you warm, that blanket. The same is true for these greenhouse gases. They retain the heat from the sun in our atmosphere. And that is actually an important function of greenhouse gases. In fact, without greenhouse gases, life on Earth would not be possible. It would be too cold. The problem is human activity produces too many of these greenhouse gases, and that makes this blanket too thick. And that leads to additional warming. And this is where the problem lies. We are producing too many of these greenhouse gases. The blanket is getting too thick. Too much solar heat is retained in our atmosphere.
Tässä nyt sitten hyvin lyhyesti tämä koko ilmastonmuutoksen syy, että ihmiskunta tuottaa liikaa näitä kasvihuonekaasuja, jotka muodostaa tällaisen, kun hän puhuu peitosta tähän ilmakehään, joka sitten pitää tämän auringon lämmön täällä maan pinnan lähellä ja aiheuttaa sitten ilmaston lämpenemistä. Ja tässä on nämä 3 tärkeää maataloudesta tulevaa päästöä.
So, of course, we're talking about greenhouse gases now, but I want to explain this slide better. Imagine we were to go drink together. We drink from the same glasses. One of us drinks beer, one of us drinks wine, one of us drinks vodka, the same volume. We all know that the effect will be different, right?
We have tested that.
The effect can be different, and how do you measure the difference? For example, with breath alcohol analyzers, right? They will tell you how many % of breath is alcohol. For greenhouse gases, you can do that too. You can measure how they differ with respect to how well they can trap heat from the sun. And the measure for that is called GWP 100, global warming potential 100. What this measure says is that one molecule of methane is the same as 28 molecules of CO2. And one molecule of nitrous oxide is the same as 265 molecules of CO2. So if, let's say, your dairy produces 10 tons of methane, all you need to do is multiply 10 tons times 28, and then you get 280 tons of CO2 equivalent emissions. CO2e it's called. CO2 equivalent emissions.
Ja tässä on sitten nämä ilmastokaasujen ilmastoa lämmittävä vaikutus, eli tämä GWP 100, ja tätä tullaan nyt sitten tässä esityksessä katsomaan aika tarkkaan. Tämä kertoo vain sitä, että näissä ilmastokaasuilla on eroja. Metaani niin kuin träppää, eli sitoo itsensä lämpöä 28-kertaisesti hiilidioksidin verrattuna, ja sitten tuo typpioksidi tekee sen lähes 300 kertaa tehokkaammin per molekyyli. Ja nyt tämä GWP 100 on tavallaan niin kuin laskentamenetelmä, jolla nämä kaikkien ilmastokaasujen vaikutus ikään kuin yhteismitallistetaan.
So just like wine being stronger than beer and vodka being much stronger than both wine and beer, we have differences across these greenhouse gases, okay? Nitrous oxide is the strongest in trapping heat from the sun. Methane is the second strongest. And because of this global warming potential 100, the world thinks methane is bad. And yes, methane is powerful. But I call methane the fast and furious greenhouse gas. Furious because it's powerful, but fast because it has another attribute. And I will show you this on the next slide. This slide here shows on the left side various sources of methane. So that includes fossil fuel production and use, agriculture and waste, wetlands, and so on, up until here. And if you look at the first half bubble on top, it says 576. You see that number 576? These are all the sources in the world producing methane. 576. What the world media does not report is that they are not just sources of methane, but if you look at the right side of this graph, you see that there are sinks of methane. And they amount to 556, the top right number. In other words, ladies and gentlemen, there are 576 teragrams of methane produced, and there are 556 teragrams of methane destroyed, naturally destroyed, a process called oxidation. The way this works is, if this here were a methane molecule, my fist, after about 10 years, it meets another molecule in the air called a hydroxyl radical. This radical destroys methane. And that happens within 10 to 12 years. And that is a very important detail to know. Methane is the only gas across all greenhouse gases that's not just produced, but also destroyed. For methane, there is an atmospheric removal. This is very important.
Yes. Tässä kuvassa on metaanin globaali budjetti. Eli tuossa vasemmalla näkyy nämä metaania tuottavat joko fossiiliset lähteet tai sitten biogeeniset lähteet. Ja tästä mediassa puhutaan tosi paljon, mutta unohdetaan kertoa se, että metaani hajoaa tämän oksidaation johdosta ilmakehässä 10-12 vuodessa. Eli tämä metaanin luonnollinen hajoaminen ilmakehässä yleensä jää kertomatta. Ja tämä on nyt tämän niin kuin koko tarinan tosi tärkeä pointti.
So what this means is, globally, we don't have to worry about 576. We have to globally deal with the difference between the one and the other. And that's in the red box. That's 13. Still a number we seek to reduce, but certainly a number much different from just looking at the sources. I think everybody in the room understands this, right? It makes a big difference, a huge difference. Why am I telling you this? I'm telling you this because GWP 100, the way we quantify methane and nitrous oxide, does not take this atmospheric removal into consideration. You have to translate that, please.
Ja nyt tullaan tähän GVP-100-laskentamenetelmään, jolla siis standardoidaan näiden eri ilmastokaasujen ilmastoon lämmittävää vaikutusta. Mutta GVP-100 ei ota huomioon, nyt nimenomaan jos puhutaan metaanista, niin tätä metaanin ilmakehästä hajoamista. Ja sen takia tähän on Oxfordin yliopistossa kehitetty uusi laskentamenetelmä, ja Frank kertoo siitä just.
But GWP 100 has been used for the last 30 years and is still being used today, everywhere all over the world. I have criticized this unit for years now, and thankfully now I have gotten some prominent support of my criticism. And now there are important developments that I will share with you. So I told you methane is powerful, but methane is not just produced, it's also destroyed. And that leads to a very short lifespan of this gas. You can see on this slide that while CO2 has a lifespan of 1,000 years, meaning if you drive a car and you put CO2 out, that gas will stay in the air for 1,000 years. Methane has a lifespan of a little over 1 decade. And this difference in lifespan of these gases makes a huge difference to how they warm the planet and how we shall account for them. What I'm showing you on this next slide is what's called the biogenic carbon cycle. And it really includes a discussion over where the carbon in the methane is CH4, where that carbon comes from, that goes into methane, and where it's going. It all starts with photosynthesis, the process by which plants take sunlight, water, and a source of carbon to produce sugars, such as cellulose or starch. They take the carbon that becomes methane from the atmosphere as CO2. That CO2 goes into our plants, and then the plants convert it into cellulose or starch. Our cows and other animals eat that plant material, and when they do, they produce some methane. Methane is CH4. See it on this slide. Methane is CH4. Is the carbon in that CH4, is that carbon new and additional to the atmosphere, or is it not? The answer is it's not new and additional to the atmosphere. It was in the atmosphere before, but in a different form, in the form of CO2. Does that make sense? The CH4 on the right slide here has carbon in it, but that carbon is not new to the atmosphere. It came from atmospheric CO2. While the methane, the CH4, is in the atmosphere, it warms up the planet. But after 10 years, it meets the radical and it is converted back to where it came from, CO2. This is a cycle. It's a short-lived cycle of carbon going from CO2 to plant carbohydrates to methane and then back to CO2. It goes around and around and around. Is this carbon cycle similar or different from other sources of greenhouse gases, such as the transportation sector or power production engines? And the answer to that is it's significantly different. The next slide here shows the main source of greenhouse gases in the world, and that is what we call fossil fuels. Fossil fuels are oil, coal, and gas. Fossil fuels used to be plants and animals such as dinosaurs. They lived millions of years ago, died, decayed, and fossilized, and became oil, coal, and gas. And over the last 70 years, humanity has taken about half of that fossil fuel out of the ground. And what did we do with it? We burned it. Where's that carbon now? Where is it? I see fingers going up. Exactly. It's in the atmosphere. And when the sun hits those molecules, they heat up. Is that a short-lived cycle? No, it's a one-way street of carbon that was in the ground for hundreds of millions of years up into the atmosphere, and there's no way back. This is a one-way street.
Hän kertoi tässä, että mikä on tämä biogeeninen hiilenkierto ja miten se liittyy tähän maidontuotantoon. Eli siis kasvit yhteyttävät hiilidioksidia ilmasta, lehmät syövät ruohon, joka on siis yhteyttäinen hiilidioksidi, siitä tulee metaania, jonka lehmät ulos hengittää, ja 10 vuodessa se metaani muuttuu uudelleen hiilidioksidiksi ja palaa sinne kasvien kautta siihen kiertoon. Ja tämä on niin sanottu biogeeninen hiilenkierto, ja tämä hiilenkierto ei lisää ilmakehän hiilimäärää. Se kiertää. Ja tässä on iso ero fossiilisiin päästöihin, jotka koko aika lisää ilmakehän. Silloin kun fossiilisia polttoaineita käytetään, niin lisää ilmakehän hiilimäärää. Ja nyt tässä oli mullekin todella pysäyttävä asia. Viimeisen 70 vuoden aikana tästä fossiilisesta hiilestä arvion mukaan puolet, 50% on ihmisen toiminnan ansiosta sitten päätynyt tuonne ilmakehään ilmaa lämmittämään.
So, in other words, people comparing cows versus cars are misleading the public in major ways. Because fossil fuels are a one-way street from the ground up into the air. Every time we burn them, we have additional carbon in the atmosphere. On the livestock side, a constant source, a constant herd of cattle will not add new additional carbon to the atmosphere, but it will recycle existing carbon over and over and over again. And that's depicted on this slide. On the left side, you see fossil carbon that was in the ground for hundreds of millions of years being extracted and then burned with cars, trucks, trains, planes, ships, adding CO2 to the atmosphere. On the right side, you see on top there CO2 that is taken on by plants during photosynthesis. A little bit of that carbon is staying above ground, but the majority is going below ground, first into the roots of the plants, and then via soil microbes in the soil. A process called soil carbon sequestration. Soil carbon sequestration. Before you translate, one more sentence. About 1/3 of all human-caused carbon that's in the atmosphere gets trapped in our soils. Guess what? You are part of that process. If you graze cattle, then your grazing land stores carbon that was previously in the air. You are part of that climate solution by storing carbon in your soils. By preserving your soils, you are capturing carbon.
Tässä on uudelleen tarkempi kuva tästä biogeenistä hiilenkierrosta, ja tässä tuli niin nimenomaan maidontuotantoon ja naudanlihan tuotantoon, kun se perustuu nurmeen, niin toinen tärkeä asia hiilenkiertoon liittyen. Frankin mukaan tässä kolmasosa nurmen tai rehukasvien sitomasta hiilestä päätyy maaperään. Ja kun me puhutaan hiiliviljelystä tai maaperän hiilen sidonnasta, niin tämä on se juuri prosessi. Eli juurien kautta hiili menee sinne maahan ja maaperän mikrobit muuttaa sen sellaisen muotoon, että se pysyy siellä pidempään. Tämä prosessi tapahtuu myöskin Suomessa, nimenomaan kivennäismailla, jossa se lähtöhiilipitoisuus ei ole vielä kovin korkea.
So here in Finland, a lot of your animal production occurs on pasture, right? Many of you have animals on pasture. What your animals are consuming is the world's #1 biomass, which is cellulose in grasses. Cellulose. Nobody else can digest cellulose but ruminants. They're the only animals that can digest cellulose and make high quality human source foods from it. What powers this is the sun. What a beautiful thing. Don't you think it's time that we explain that story to the public that thinks ruminants are the worst thing in the world? What better way of using your grassland is there to putting ruminants on it? You tell me. What way is more sustainable and producing food than the use of ruminants on grassland? You tell me that. And now let's tell that story together to people who need to know. Now, of course, our cattle eat some of the above ground vegetation. That cellulose, when it gets into the bovine, ends up in the rumen. Microbes convert some of that carbon into methane. The cow belches it out. And then after 10 years, it becomes CO2 again. Okay? This is a biogenic carbon cycle. It goes around and around and around. It's not the same as the fossil fuel one-way street. When people compare cows versus cars, you should speak up. It's not the same. Not the same. That does not mean that this methane doesn't matter. While this methane is in the air, it traps heat from the sun. I still, and I want to be very clear about that, I'm very clear that I say methane is a problem if we don't manage it. Because methane is nothing other than energy. You can burn methane and make power from it. You can convert methane and make it into fuel. Methane is energy. Energy is money. About 10% of the energy that you feed into a cow gets lost as methane. 10%, poof, gone. This is like you leaving your windows open in the winter and heat escapes. Makes no sense to waste methane. We don't want to waste methane. We want to use methane and we want to do it in a smart way. And then we convert it from a problem into a solution. So colleagues from Oxford University in the United Kingdom years ago said the way we are accounting for methane and its impact on climate is wrong. GWP 100 does not do a good job on converting methane into warming. In fact, the only thing GWP 100 does is convert methane into CO2 equivalent units. It does not tell us what the warming impact is of methane. So they said years ago the following. They said that if you have a constant source of methane, let's say a constant cattle herd, and you use GWP 100 to quantify it, then you are overblowing the impact of that methane source on warming by a factor of 3 to 4. That's what they said years ago. I have said it for years, and my critics said Mitloehner is downplaying the importance of methane. I am not downplaying the importance of methane, but I'm saying if this gas is not just produced, but also destroyed, then we have to account for that. Those colleagues from Oxford then developed a new matrix called GWP star. And this new matrix actually does account for the impact of this gas on warming. It accounts both for production and destruction of this gas. GWP star it's called, and you will hear this in the future, I promise.
Nyt päästiin tähän uuteen laskentamenetelmään, johon jo äsken viittasinkin. Eli jos kerrataan, niin tämä GWP 100 laskentamenetelmä biogeeniselle metaanille yliarvioi tämän lehmien tuottaman metaanin ilmastoa lämmittävän vaikutuksen 3-4 kertaa liian suureksi. Ja nyt tämä GWP Star, joka on tämä Oxfordin yliopiston uusi menetelmä, ottaa oikeasti paremmin huomioon sen, mikä sen lehmien tuottaman metaanin todellinen ilmastoa lämmittävä vaikutus on. Kohta kuullaan.
The world's leading body on climate and climate change is called the IPCC, Intergovernmental Panel for Climate Change. The IPCC last year, in their report called AR6, thankfully said exactly what I just told you. And I quote, in their report from last year, they said, expressing methane emissions as CO2 equivalent emissions using GWP 100 overestimates the effect of constant methane emissions on global surface temperature by a factor of 3 to 4. Let that sink in, okay? The way we have quantified methane for the last 30 years overblows the impact of this gas on warming by a factor of 3 to 4. And the whole world is pointing their fingers at you and your ruminants, saying how terrible you are. And it all hinges on methane. You understand the significance of this, right? This is huge. I'm not saying let's stop using GWP 100 because the whole world is using it, even though it's wrong. but let's at least use GWP star in parallel so that we help our farmers understand how they can reach certain goals and what means they can deploy to get there.
Ja tässä on kuvassa on leike tuosta IPCC viimeisimmästä raportista, joka julkaistiin viime vuonna. Ja tässä kerrotaan tämä sama tuossa korostetulla kohdalla, minkä Frank äsken sanoi, että tämä vanha laskentamenetelmä, jota on 70 vuotta käytetty, tosiaankin yliarvioi tuon metaanin vaikutuksen 3-4-kertaisesti ilmaston lämpenemiseen. Ja nyt Frank tässä sanoo, että nyt tätä on käytetty sitä vanhaa GVP-100-menetelmää niin kauan, että me ei siitä ihan helposti päästä eroon. Mekin esimerkiksi paljon karbonlaskuissa käytetään tätä vanhaa menetelmää. Meillä on jo mahdollisuus ja ajatukset käyttää uutta menetelmää rinnalla, aivan niin kuin Frank tässä ehdottaa.
On this next slide, I show you a direct comparison of how GWP 100 compares to GWP star. And I show you 3 scenarios. The first one is the top one, where over 30 years, methane increases by 35%. This actually happens in some developing countries where they grow livestock herds and that increases methane. Okay? The second scenario is one where methane is relatively stable, where we maybe slightly reduce methane over 30 years. And the third scenario is one where methane is being reduced strongly by 35% over 30 years. How do these 3 scenarios, the increasing, the stable, and the decreasing methane scenario, how do they look like when you use GWP 100? GWP 100 would say that in either one of those scenarios, we would add a lot of additional CO2 equivalent emissions. But we know that that's not true because this gas is not just produced, it's also destroyed. So if we reduce emissions, then there's no way that we can add that much CO2 equivalent emissions. So now I show you what GWP star says, the new matrix from Oxford University. The new unit from Oxford University, GWP star, only agrees with GWP 100 in the top scenario. When you have constant emissions, like in the second scenario, or slightly reducing, you see 10% reduction, then you don't see any blue north of the x-axis, meaning no additional warming is occurring because you hold methane stable over time. If you reduce methane, and this is really important now, if you reduce methane, then not just don't you produce positive warming, you produce negative warming, meaning you are taking carbon out of the atmosphere. You are reducing warming. If you reduce methane, you reduce warming. And GWP star shows that. GWP 100 doesn't show that. You can never reduce warming using this old matrix, which is wrong. But is this possible? Can we do this? Can we do a strong reduction of methane in any region in the world or everywhere? That's a question people ask me. Go ahead.
Nyt tulee todella tärkeä pointti. Eli tässä on 3 skenaariota metaanituotannosta. Eli sellainen skenaario, jossa metaanituotanto lisääntyy 30 vuoden aikana, tai se pysyy samana, keskimmäinen, taikka sitten, että metaanituotantoa voidaan vähentää. Tässä tapauksessa 35%. Ja tässä on sitten näiden laskentamenetelmien ero. Eli täällä GVP-100 ei saada näkyviin sitä, että kun vähennetään metaania, niin sillä on ilmastoa jäähdyttävä vaikutus. Kertaan vielä, ilmastoa jäähdyttävä vaikutus. Tämä alin skenaario tässä. Ja mä vastaan tuohon Frankin kysymykseen, että onko meillä teknologioita vähentää metaania? Vastaus on, että on. Valiollakin ollaan testattu sellaista, jolla noin 30% saadaan metaanista pois.
In California, we have the strictest environmental regulations. With respect to methane, there's a new law that mandates that our farmers need to reduce methane by 40%, 40, by the year 2030. I stood in front of hundreds of dairymen in California and they said, oh my God, how can we do this? Yet another law. They were very disappointed. But little did they know at the time that the California legislature had a special plan to achieve of 40% reduction. Namely, the plan of not using rules and regulations and taxes, which I call the cane approach, but to use the carrot approach of financially incentivizing methane reduction.
Kaliforniassa on laki, jonka tavoitteena on 40% metaanintuotannosta vähentäminen maidontuotannossa. Nyt osavaltio on panostanut todella paljon rahaa siihen, että esimerkiksi näitä kuvassa näkyviä metaanindigestereitä on näille tiloille tullut. Eli niin kuin Frank sanoi, tässä mennään porkkanalla. Siis me tälle elinkeinolle annetaan rahaa, jotta he voivat tehdä tätä työtä. Ja siellä on jo viime keväänä siellä vierailtiin, ja näitä digestereitä on kohta 200 kappaletta. Eli ne on todella hurjalla vauhdilla. Ja nyt kun siellä on lämmin ilmasto, niin täällä näissä lantalakuneissa, jos ei tehdä mitään, niin sieltä tulee paljon metaania. Sitten vapautuu ilmakehään. Ja tällä tavalla näillä digestereillä ne on voinut sitten jo tällä hetkellä niin 30% pudottaa sitä metaanin tuotantoa.
So the state of California partnered with the dairy industry and helped the dairy industry make changes. For example, the state of California helped farmers put in covered lagoons. These are digesters. They just look different compared to the ones you have here. They are larger. And what you see bulging out here is biogas. This is biogas. This biogas is 60% methane. But in contrast to European digesters, where you burn biogas to make power, the California digesters, the so-called covered lagoons, are used to capture the biogas and make the biogas into fuels for heavy-duty trucks, like semi-trucks and buses. And this is what it looks like when you have dairy renewable natural gas that comes from biogas going into heavy-duty trucks. The goal for our dairy industry is to reduce 7 million metric tons of greenhouse gas. 7 million is the goal. Our dairy started 3 years ago with the reductions. We already have 2.5 million metric tons reduced. And our dairies are making money by doing so, because the state financially incentivizes it. If you consider that the average cow in California makes $4,000 for the sales of milk, the average cow in California now makes $2,000 for the sales of biogas. And that makes this whole thing financially attractive. And our farmers are flocking into doing technologies like this. On the research side, we do, so 30% of the reduction goal has already been achieved by our dairy industry. And our state's agencies are impressed. They are impressed with our dairy industry. It's not just animal manure reductions that help us get to our goal. It's also research into feed additives. Feed additives that reduce enteric methane, the methane that comes out the front end of the cow. Here there are many different types of additives. Some of them don't really work. Most of them don't really work. But some of them work and work really well. And we are now identifying which additives these are. There's now also research into a vaccine for methane in New Zealand, and more research into a bolus for methane. And after you translate that, I will show one more slide and then I shut up. Go ahead.
Eli tuossa edellisellä karvolla, tai edellisen karvon kohdalla, Frank kertoi, että per leppä, siis vähän yli $3,000 tulee niin maidosta. Ja noiden digestereiden kautta, kun ne myy sen biokaasuna sitten liikenteeseen, niin saadaan lähes $2,000 lisää. Aika huikeeta. Ja tämä on niin kuin tietysti Kaliforniasta mahdollista. Meillä lantavarastoissa niin viileän ilmaston takia ei tietenkään tule tämmöistä samanlaista niin kuin päästöä näistä lantavarastoista kuin Kaliforniasta. Ja sen takia siellä on niin kuin iso juttu tuo digesterihomma. Tästä kalvolla kerrotaan noista rehun lisäaineista, joita siis mekin ollaan valiolla testattu ihan käytännössä. Siellä on toi kolmantena tai neljäntenä toi Trino, jota me ollaan testattu, ja sehän vähentää 30%. Siis lehmän tuottamaa metaania, ei se varastossa enää vaikuta. Ja nyt tuolla Kalifornian yliopistossa tutkitaan näitä hyvin intensiivisesti, mitkä oikeasti toimii ja mitkä on käyttökelpoisia.
So what we have learned is this: if you reduce methane by enough, let's say 30%, then the reduction of methane generates so much negative warming, which is the same as cooling, to offset other greenhouse gases such as nitrous oxide and CO2, getting the dairy or the livestock operation to a point of climate neutrality. No more warming, additional warming caused by this dairy, if you reduce approximately 30%. And that's achievable. We are seeing this in California now. In fact, we've done predictions as to when our whole dairy industry, and that's an industry with 2,000 farms, and the farms are large, 1,500 cows per dairy, when this dairy industry can be climate neutral. And what we found is this: by the year 2027, our dairies, if they reduce methane from manure by 40%, they will achieve climate neutrality by 2027. And if they do both methane reduction from manure plus enteric reduction, then they will be even more aggressive. That's the dark blue versus the light blue. Business as usual will not get us to climate neutrality. But if we reduce methane, then we have a real tool to not just get rid of our own warming impact, but become climate negative, meaning we can now sell our credits to other industries. That's already happening. We now have California dairies selling carbon credits to BP, to Texaco, to BMW and Mercedes. And dairy farmers are getting money for reducing their methane. And that, ladies and gentlemen, is how it works. It does not work with taxes, regulations, and fines with a cane approach. It works with a carrot approach of incentivizing these reductions. Surprise, surprise. We should all know that. Unfortunately, currently, that's only happening in California, nowhere else in the world. I hope if your politicians come around dealing with methane, that they look around in the world where it works and where it doesn't. So with that, I'm coming to a close here. Just give you my Twitter handle is GHGGuru. If you are on Twitter, I hope you follow me. And my webpage for the CLEAR Center is here, clear.ucdavis.edu. I hope that you find this useful. And I thank you so much for inviting me. Thank you for your attention. I'm happy to entertain any questions you might have. Thank you.
Ihan lyhyt käännös kahdesta erittäin tärkeästä termistä. Hiilineutraalisuus ja ilmastoneutraalisuus on kaksi hieman eri asiaa. Nyt kun Frank puhuu ilmastoneutraalisuudesta, hän puhuu siitä kohdasta, missä metaanituotantoa vähentämällä saavutetaan ilmaston viilentävää vaikutusta, joka kompensoi muita arvoketjupäästöjä. Ja nyt kun me ollaan, muun muassa paljonkin ollaan puhuttu hiilineutraalisuudesta, se on vähän eri asia. Silloin me laskemme tällä GDP-100-menetelmällä, ja se on huomattavasti vaikeampi saavuttaa kuin tämä ilmastoneutraalisuus. Ja mä oon eilen ja tänään Frankin kanssa puhunut aika paljon tästä, että meidänkin on ilman muuta lähdettävä laskemaan näillä kahdella tavalla. Niin kuin näitte tuosta, että 30% metaanituotantoa vähentämällä Kalifornian maitoala pääsee ilmastoneutraaliseen tilanteeseen vuonna 2027-2028, niin kuin näitte tuosta kuvasta. Ja se tarkoittaa sitä, että se arvoketju ei aiheuta enää yhtään lisää ilmastolämpenemistä. Eli se on ilmastoneutraalisuustilanne. Se hiilineutraalisuustilanne on sitten tällä vanhalla laskentatavalla laskettu tilanne, jossa hiilipäästöt GDP-100 laskettuna on sama kuin hiilen sidonta. Tämä on tosi tärkeä kohta. So the question is about the food waste. So what do you think about the food waste? What we should do about that?
The food waste? Oh,
okay.
Well, actually, I do have a slide on food waste. This one here. Don't know if you can see this. Can you see this slide? This slide shows an American family in front of all the food they buy but never eat. 40% of all the food produced in the United States, 40% of all the food produced in all developed countries, and even in developing countries, 40% of food goes to waste. In developed countries because of consumers, our kitchens and restaurants. In developing countries because farmers can't get the harvest to the markets. 40% is a travesty, it's a huge problem, and the number one issue or the number one environmental issue of our food supply chain. That's it, that's the number one. If you want to reduce the environmental footprint of food, then that is the number one issue we have to address. And it's not belching cows, that is the number one.
Eli lyhyesti Frank vastasi se, että numero 1 toimenpide ilmastonäkökulmasta ruokaketjussa on se, että me vähennetään tämä ruokahävikki selkeästi tästä. Eli globaalisti kehittyneissä maissa 40%. Ja myöskin kehittyvissä maissa, niin kuin hän sanoi, se kuulostaa järkyttävältä.